Unger here with another edition of Ask an Astronomer. And of course, we are joined by our trusty astronomer, still working from home, but hopefully we will get an appearance from Emily the cat. And that is our astronomer, Marley. Hey, Marley, how's it going?
Hello, I'm good. How are you?
Not bad. How's Emily doing over there?
Well, she's sleeping now, which is all she does every day, but I bought her a new pet bed recently and she likes it a lot, so I'm happy about it.
Excited. Well, maybe she does wake up. Maybe we'll see. Have a special guest
Special
appearance
guest.
to add on to some fun topics that we have for today's show. Of course, thank you so much for everyone joining us here in YouTube. If you have any questions, stuff you've been learning about, stuff you've been reading about, we've got half an hour to answer all of your questions. Put them into the chat window on YouTube. If you're out there in telescopic land, come on and join us in YouTube so you can ask some questions. But to start us off, to get all of your brains inspired thinking about space, we've got a couple news stories that have been buzzing around up there in space. And of course, to inspire us, let's talk about Inspiration4, the latest SpaceX endeavor.
Yeah, so this is actually pretty recent. They launched yesterday. So Inspiration4, for some background, is a all civilian mission. So no one on board has any astronaut training whatsoever. Well, not whatsoever, but they're not officially trained astronauts at all. And it is operated by SpaceX on behalf of Jared Isaacman. Jared Isaacman is the CEO of a company called Shift4 Payments, which sounds like a point of sale payment company. And this was being done in an effort to raise awareness and money for St. Jude's Children's Hospital, known largely for their research in childhood cancers and things like that. So the crew was announced in early 2021 through a variety of different means. So this is the crew who's currently on board the Dragon capsule. And they did it to have four members that represent the four mission pillars. And the pillars are leadership, hope, generosity, and prosperity was the idea behind this. And so in order from left to right, we have Chris Zimbrowski, which represents generosity. We have Dr. Cyan Proctor, who is there for prosperity, was her ticket awarded under leadership. We have the CEO, Jared Isaacman, and hope we have Haley Arsenault, who is a childhood cancer survivor, who actually got treatment at St. Jude and now works at St. Jude as a physician's assistant and was selected by St. Jude's Hospital to board the flight. And all of these people have very different backgrounds, but all have a love of space and space exploration and space science.
This is really exciting because one of the things that SpaceX and even some of the other private companies that are now going to space, they're sending different kinds of people into space. I think that's one of the takeaways that I find really exciting is they're sending more diverse people that aren't just, in the military, that of course know how to fly planes. And that's one of the big things that you need to do is operate a spaceship going out there, especially if it's docking with the International Space Station. But for instance, Dr. Proctor, someone who may not have had a chance to go up in space before, but definitely is leading this mission.
Yeah, the interesting thing about Dr. Proctor is that she was actually part of one of NASA's astronaut classes back in 1999, but was ultimately passed over for any mission. So this really is like her shot to get to go. And she's currently a professor in geoscience and has been for over 20 years. And is currently on reassignment as an open educational resource coordinator for the Maricopa Community College District. She's very interesting. I really admire her and her work. But she was chosen for the flight by Shift4 Payments after like a Shark Tank-esque competition that rewarded the best business idea that would make use of Shift4's commerce solutions and innovations. And she's actually an analog astronaut. So she conducts activities in simulated space conditions. And she's actually done 4 different missions as an analog astronaut. One of them being the High Seas mission where they simulate a Martian environment. So she's, very cool.
That's amazing. Everyone out there that's watching right now, put it to the chat if you would go out on one of these missions. If you got a free ticket, I would definitely go for sure. But not everyone would. But what about you, Marley? Would you go?
I lean more towards yes on this one as opposed to some of the other ones, mainly because they're actually up there for 3 days, which seems
Okay.
like a reasonable amount of time as opposed to 5 minutes. Also, I think it was the all the money raised. You didn't have to buy a ticket. All the money raised. The endeavor was to raise, I think, over 200 million US dollars for St. Jude's Children's Hospital, which
Right.
I think is very admirable. So I would lean more towards yes on this one, though I still maintain if I were to go to space, I want to live on the International Space Station for like a couple weeks.
Yeah, that would the full experience, if you will.
Exactly. I want the full experience.
Awesome. So is there anything more on Inspiration4 that we need to know about? Like you said, what were they really doing up there?
Yeah, so they're performing a variety of medical experiments and recording health data to support future human space flights because this crew is not trained the same way professional astronauts are trained, right? So they're just people, they did receive a lot of training, but not as much as professional astronauts would get. So usually professional astronauts have a much more intensive training schedule. The crew was announced in March of 2021 and they launched in September of 2021. So that training window is a lot smaller than normally would be for professional astronauts. But they did undergo lessons in orbital mechanics, working in a microgravity environment, stress testing, emergency preparedness trainings, mission simulations. And actually all of their mission preparation work and the mission itself is being documented in a 5-episode series on Netflix that should be coming in September of 2021. So sometime this month.
Amazing.
No, it's very cool. What's also very awesome about this, so they launched from NASA Kennedy Space Center in Florida at 6:02 Pacific time yesterday, last evening. And they were in a Crew Dragon spacecraft, the same that they used to send crew to the International Space Station, and the Cargo Dragon, similar thing, on top of a Falcon 9 rocket. And the Falcon 9 rocket was actually able to land on its barge, so it's a reusable rocket. And the interesting thing about the Dragon capsule they're in is that they've actually removed the docking mechanism off of the capsule and replaced it with a glass dome. I cannot pronounce this word for whatever reason. The cupola. That's wrong.
Copula?
Yes, copula. Yeah. So the astronauts have a chance to look outside and observe Earth while they're on their 3-day trip. So I thought that was just pretty neat. So I'm glad it was a successful launch for them. I'm glad they were able to launch on the day they wanted. Conditions were favorable, and they should be splashing down sometime Saturday the 18th or Sunday the 19th.
All right. So it's not a fully complete success yet until they return to Earth safely, right?
Yeah, they've successfully done everything so far, but there's still the stressful time of coming back is always kind of stressful. So my best wishes to the crew.
Absolutely. Well, looking forward to hearing more about these private space missions, the private companies sending up new and diverse, interesting people up there in space. It's going to just keep getting bigger and bigger. And I love the fact that it is connected to a charity. I think that's wonderful. And of course, I'm just going to sneak this in as since we're talking about launches, we might as well stick to another big launch that we've been looking forward to later this year, which has been changed again. We kind of knew that it was the date was going to get changed, but JWST, James Webb Space Telescope, now has a new date for launch, right, Marley?
Yeah, it does. It was announced that they're aiming for December 18th, 2021 now. So this comes after tons of delays and things like that, but they are aiming to have the telescope and the rocket that it will launch on, the Ariane, I think 5 rocket, in the port in French Guiana and launching on December 18th. So excited for that. Fun fact, we will not know, we'll only know when JWST arrives in French Guiana because it has to go there by barge. And so they will not release when it is leaving or its path through the waters for fear of piracy, which I thought was very, I don't know.
What would pirates do with a giant space telescope?
It costs a lot of money and there's gold involved in the production of it. Gold's a really good element for some stuff. But I also think that if they're willing to steal something that big, then I think they should, have it, I guess. That's a lot of work for something that you may not use ever.
And then they got to send Captain Jack Sparrow on a mission to get the telescope back. And then all of a sudden, this becomes a Netflix show.
Oh,
Maybe this
man.
is their end goal all along here.
If the end goal for JWST is just to be stolen, I think I'll resign. I think that'll be it for me.
All right. Well, that's not going to change our programming either. Originally it was slated to be October 31st at the launch. So November was going to be a month that here at the Space Center, we were going to do a lot of programming around JWST. That's not going to change. We're going to have, of course, a cosmic night that is going to feature a scientist. Don't know which one yet, but the Canadian Space Agency, Canada, is involved with the James Webb Space Telescope. So we're going to be doing a lot of programming here in the building as well as online. So check out our website for some of that information coming up in November. But we've got another really fun story to get to here, Marley. And of course, the last few Friday nights that I've been working here, we've been using our telescope. I saw Jupiter through the telescope last Friday, just beautiful. But somebody else was looking at Jupiter as well and found something interesting.
Yeah, this is a really exciting story. I love when things like this happen. So there was an impact on Jupiter on Monday, detected and first seen by Jose Luis Pereira, who is a Brazilian observer, amateur astronomer, and he set up in São Caetano do Sul, and he wanted to capture videos for the DETECT program. And so the DETECT program is a program made specifically for Jovian or Jupiter impacts. And it is actually made by Marc Delacroix and also developed by Jean Jussarti. And Marc Delacroix is with the French Astronomical Society. So you can actually download the program yourself if you're into astrophotography, monitoring Jupiter and that sort of things, and send your images to Mark, and sometimes you get a detection just like Jose did. So in this photo, we have of Jupiter, and then we have this flash kind of in oh, I don't want my pen. I want yes. We have a flash on Jupiter itself in that little red spot there. So that is where something hit Jupiter. And so the impact occurred and was confirmed to have occurred on Monday, September 13th at 6:39 p.m. Eastern Daylight Time. And this photo is very cool. This is from another astrophotographer, Damien Peach, and he obtained a photo of Jupiter an hour after the impact, completely healed up and totally fine. So the idea is that the object was too small to reach the deeper atmosphere, so we didn't get any of that scarring that is common that we saw with like Comet Shoemaker-Levy 9 or the 2009 impactor of Jupiter.
This is really incredible. So, so far, is this the only image? Was Jose the only person to have captured this impact?
If I was reading it right, yes, I think he was at least the first. So he was the one who saw it, got the picture, his data came in first. And so just happenstance, he was just watching the skies. I was reading the space.com article written up about him and this image, and he said that Jupiter is his favorite object in the sky to photograph. So I love when amateur astronomers find something that professional astronomers don't, because this happened so quickly and dissipated so quickly. Astronomers weren't able to turn any of their telescopes to it, get any images of it, and it's really because Jose has this wonderful hobby of looking up at the sky that we know that this even happened.
This reminds me, Marley, one of your main jobs here as an astronomer at the MacMillan Space Center is that we have people call in and say, hey, I saw something, interesting up in the sky. This actually happened, to me actually last week. Saw something interesting. But now, because so-called, amateur observers are getting better and better and now observing things with telescopes, we may start to see images like this, maybe even coming into you, Marley, and be like, hey, I saw something weird on Jupiter. What is it?
Yeah, I mean, if that happens, I'm going to have to turn you right to Mark's programming software, because I was taking a look at it, and it's very interesting that, the great thing about astronomy is that there's so many questions, and, you think you're very alone with your questions, but if you throw a rock and you know what to look for, you're probably going to hit somebody who has the same question you do. And just Mark has done this, the whole program, the whole software developed is specifically for things that hit Jupiter, which I just think is marvelous, very interesting.
Wow, really interesting. Now, if we just stay on this image just for a second, of course, if anyone out there on YouTube has any questions, we can get into this. But let's just talk about Jupiter for a minute here, because there's a lot going on the so-called surface of Jupiter. But we know that those lines, they're not surface that we can walk upon. This is all a gas giant planet. So what actually is making an impact? Like if you hear people say, or you just said that Jupiter's been impacted, but it's not, of course, causing a crater, but that bright flash of light. What's actually causing that bright flash of light if it's impacting just gas?
Yeah, so think of it like when something we see like a meteor in the sky, like a shooting star. You get that bright streak of light as the thing burns up in the atmosphere. Jupiter is basically just like essentially a big ball of gas, right? But that gas is made up of different particles and things like that. And so it's the object like dissipating and breaking up is what you get that big flash. And then the scarring, that's not seen in this image, but is seen in like the Shoemaker-Levy image. Like these scars are from when layers of the deeper atmosphere and the upper atmosphere get disturbed and churned up, and things get kind of mixed up, and you end up with this scar that has to settle itself back out.
Yeah, really interesting. And of course, that Shoemaker-Levy observation was a pretty big one because, of course, that was also a discovery, of a comet as well. So, is there any speculation as to what perhaps caused this impact? Obviously, some sort of large rock, but maybe not as large as a comet.
Not as large as a comet. I wanted to bring this picture up specifically just to remind ourselves that Jupiter is really big. Like it is really big. Like there's Earth compared to the Great Red Spot, the storm there, it's big. And so with it being so massive, it has a big gravitational pull. So things just get drawn into Jupiter, right? There's a big theory that the reason Earth is not hit with as much things as it is because Jupiter acts as a shield, and pulls things in and protects us that way. And there's also a good chance that we won't see all the impacts that happen on Jupiter because Jupiter itself is quite bright. And it's not that it generates its own light. It's just that the light coming off of it is brighter than the objects that may hit it. And so we may not actually see it. And a lot more things may hit Jupiter that we don't necessarily know about as well. And because it's so big, it pulls in all those things that hit it. So it may not have been a comet. We may actually never know what it is. A lot of the Shoemaker-Levy was different because it was a comet that had broken apart into several different pieces that was noticed. And then because it was different pieces, astronomers were able to study it before it started to collide with Jupiter. Whereas in impacts like this, we only notice the collision. And because it's such a small piece that hit it and it disappeared so quickly, there goes all of our chances of studying what could have happened. There was an impact in like 2009 that left a blemish. This is the blemish from the 2009 impact. That's roughly the size of the Pacific Ocean. And so they think that the thing that hit that caused that blemish was approximately 200 to 500 meters in diameter. So for something to not leave a blemish, it was probably very small, and there's really no way of us knowing what exactly it was.
But when you say relatively small, I mean, Jupiter's still a big planet. So, if it's making that bright of a flash, it must have still been pretty big.
Yeah, pretty big, not big enough to leave a mark, which this is the curse of astronomy. It's like, oh yeah, the sun's whatever, but the sun's massive, but compared to other things, it's really not. Yeah.
Yeah. Like I can imagine if this had hit Earth, things would have not gone well.
Yeah. Real bad if it hit us. Yeah. Not good.
Yeah, so this, brings up one of the main things that NASA and a lot of other organizations that have really been, really pushing for is that, planetary defense has really been lacking, and really a lot of the asteroid detection missions. We thought we'd have more of them by now, and this should really be, an alarm bell, a wake-up call that there are things out there that could be a lot worse than a pandemic.
Could be pretty bad, but I think they're doing their best. There is also the problem with detecting asteroids and comets and near Earth objects, as they're called, is that we really only look one way, and that's like away from the sun, right? If things are near the sun is too bright and we're not able to see them at all. And so it's kind of waiting for technology to play catch up with what we'd like to do is a big part of it.
Interesting. So a couple of questions about observing Jupiter. Keith is wondering about, isn't there multiple telescopes and cameras always looking at Jupiter? with software looking out for changes in the image, things like that? Are you aware of any?
I'm not aware of any like right now. I know that they can quickly move things. The thing with professional telescopes is that you have to apply for time on the telescope. And so where that telescope is looking may not be anywhere near Jupiter. So I'm not aware of any professional like robust systems that are constantly looking at Jupiter. This one was just interesting because it was an amateur astronomer and the data was later confirmed by someone who is part of the Astronomical Society, but they're not necessarily always looking for these small events.
Interesting. So the thing is, there is also a satellite that is orbiting around Jupiter right now. Is there any possibility that Juno may have seen something?
I don't think so. Juno was, last I checked in with Juno, was looking at the moons and so was not focused on Jupiter. Additionally, Juno has like a really great camera, but there's also the possibility of this. I'm not entirely sure what Jose's setup was, but different wavelengths of light play into it. Different telescopes look at different wavelengths of light. And so not every telescope sees the same image of Jupiter at the same time.
Right. So if we just stay on that for a second, there's a reason that Jose was probably interested in doing this kinds of work. Of course, he's not getting paid for this kind of work. He's doing it mostly for fun. But a lot of people do this kind of work, taking raw images, and then processing them, and so something that's called astrophotography. Could you maybe talk a little bit about, some of the things that someone like Jose or maybe other people, perhaps like Kevin Gill, who I spoke to last year, one of the top photography experts out there. What are they really doing with an image when it comes down and accentuating it so that it looks pretty to our eyes, but they're actually have some usefulness to the image as well?
So it does depend on what you want the image to convey. If you want it to convey scientific information or if you want it to look nice, you will do different things with the image. I know for Jose's, from what I understand with his setup, was that he had a telescope with the camera mounted on the eyepiece of the telescope. So it was just taking pictures of what the telescope saw and putting it through the software. The software was just meant to detect impactors. And so it wasn't necessarily making the image prettier. When you do that, you are in the context of, I'm only familiar with like telescope data because I've never really done astrophotography from cold Calgary. So the clear nights are -30. So in the context of the telescope images is that they actually take them in different wavelengths of light, blue, red, and green. And then they get all those images down in raw image format and they layer them over top of each other to get a composite color image of what they can see. And there's also a software that will go through and that they put the image through to subtract out noise caused by the instruments taken using the photographs. Like Hubble uses a CCD camera, which is a charge coupled device. And those will have the coupled device is excited by energy, and that excited message is sent to the computer, which takes the data anyways, but that it being itself an instrument provides noise. And so there's special software that subtracts the noise based on, what type of camera you're using. So it's a lot easier than I'm making it sound, mainly because the software has been written and made for you to use it, as opposed to having to do it all on your own.
Yeah, really interesting. If you'd like to learn more, that conversation that I just talked about with Kevin Gill should be on our YouTube page. Just type in Kevin Gill as a special bonus interview that I did for a Cosmic Night last year. And it actually randomly found one of his images that was just in our gallery of Jupiter that he had processed. He got a good kick out of that. Because whenever you see an image, there's always an image processed by credit. We like to always do that as well. You can even see in the bottom right corner, we see E. Ensman and D. Peach for that image of Jupiter on the side. So there's always somebody, and usually a lot of what so-called amateur astronomers that are processing these images. All of NASA's images are public domain. So you do have to be careful, because if somebody does process their own image, they could copyright it, like their version of the image. But most often than not, people like Kevin Gale sort of give it back to NASA so they can also use the image, and any public can also use the image, and places like us can also use the image as well. So I've got a few more questions to get to before we end today. Let's just stick with the asteroids and kind of the asteroid detection. Pride was asking about radio telescopes. So would those detect the ones that would be coming from the sun? Because you were talking about a lot of the telescopes pointing away.
Yeah, so not necessarily, because things that come with radio emission, we have only a certain window that we can get radio data to and from with our atmosphere. And so if it falls outside that range, we won't be able to see it coming. And also it may not emit in the radio at all. Usually asteroids and things like that will, when they're heated up and stuff like that, will emit in like the infrared or something like that. And so one thing that they're trying to do, I know, is to send something up with what's called the coronagraph, which is something that we've done before. SOHO has a coronagraph on it, which is a heliophysics observatory studying the sun. And what it does is that coronagraph actually blocks out the sun when it takes images. And so that light is already blocked out. And using that, they've been able to discover a lot of comets and things that way. So that's probably the way they'll go with asteroid detection, is to just have a coronagraph, because that works and is a bit easier than trying to do a different emission method.
Right. Yeah, makes a lot of sense. Let's go to another question from MyCap19. So in our solar system, of course, we talked a lot about Jupiter, but which ones have been the most studied? So Jupiter and Mars are currently the two main planets that we're studying right now. What are some of the updates on some of the other planets in terms
that
of
we're
missions?
studying? There's a bunch of missions coming up for Venus, which I'm very excited about, because I do love that hot little planet. That's coming up. There's also missions, not necessarily for Saturn, but for one of Saturn's moons coming up as well. But that's
the Dragonfly mission.
The Dragonfly mission is coming up. Yeah. And for Venus, it's Veritas, Da Vinci Plus, and Envision. And Veritas and Da Vinci Plus are through NASA, and Envision is through the European Space Agency. So those are coming up. And there's actually a lot of missions going back to the moon, which I think is very exciting, because we did learn a lot about the moon, but there's always more to learn as our technology improves and changes.
Yeah, and then of course, the other mission that I can think of is JUICE and the Europa Clipper, going back to Europa. But I guess that leaves out a lot of other places. Of course, Mercury. Mercury does have another mission coming up soon. Wasn't there the not NASA mission that was going back to Mercury? I thought there was another mission that was coming up to Mercury. And then, of course, the two other gas giant planets that have not been visited in a very long time, and that is Uranus and Neptune. Those were back in Voyager days, back in the 1980s.
Yeah, well, those ones are not as well studied because they take a very long time to get there. And so that's a lot of time and return. The most recent one that got to Pluto, like New Horizons, right? And that launched in 2006, I think. And so it's very difficult to get there. And so in terms of funding and, they want to see a return on investment relatively quickly. And so it's a bit easier to go to Mars and swing around and get to Jupiter's moons than it is to get all the way to Uranus or Neptune. I'm trying to figure out the Mercury thing.
Bepi Colombo. So it is on its way. It'll arrive in 2025.
Okay. That's the other. Yeah, it takes a long time to get there, even for the close ones. And it's not like the planets are still, right? You gotta chart out the path and fuel, and it's a lot of work to get to one spot. And so the closer, the better.
Absolutely. Well, thank you so much, Marley, for answering all of those questions. Here at the Space Center, we've got lots of fun stuff happening. Astrophotography. We even have a little fun activity if you want to come and do that over in an observatory on clear days. We are looking at the sun as well, and our planetarium is open for visits. And if you're a homeschool teacher, we've got lots of homeschool sessions, one every month. Check our website for some of those, as well as if you know some teachers out there, we've got lots of our school bookings ready to go as well as we head into a brand new year. We've got some links here.
Yes, so this is just the link to the photo from Damien Peach. That was the photo of Jupiter healed. And then the Flickr link is for Jose's entire Flickr profile. So all the images he's taken of Jupiter, including the one with the impactor, is very cool. I recommend taking a look as well. Astrophotography is fun. Look at it all you can.
Absolutely. Maybe I'll even try to take some photos with I got a brand new iPhone. It takes really good photos. It's kind of hard to take photos through the telescope, but I'm going to give it a shot. I'm working tomorrow night if it's clear. All right, everyone. We will be back here on YouTube land in 2 weeks, in 2 Thursdays from now. Make sure to join us at 2 p.m. Pacific time. Until then, see you next time.
Bye, everybody.